Ladies and gentlemen, a very good evening to one and all present here. I am Vinayak Sharma, a core member of AWS User Group Dehradun, and I am thrilled to welcome you back to day 4 of our AWS Generative AI Bootcamp. In week 1, we engaged in insightful discussions, witnessed practical demonstrations on AWS Management Console, and delved into the fascinating world of neural networks and generative AI models. We also explored Party Rock and had an incredibly engaging session on AWS Bedrock, which received a fantastic response. Today, we promise to deliver even more value as we delve into the crucial topic of data strategy for GenAI. Thank you all for joining us on day 4. Your presence here reflects your commitment to learning and exploring cutting edge technologies in AWS and generative AI. Today, we are honored to have Reethi Joseph with us. Reethi is a senior cloud engineer at AWS, bringing a wealth of knowledge and experience in cloud computing and data strategy. Her expertise spans various aspects of cloud infrastructure, and she has been instrumental in driving innovative solutions at AWS. Reethi will be leading today's session on data strategy for generative AI, where she will share valuable insights and practical strategies to leverage data effectively for generative AI applications. Today, we have an exciting agenda lined up. Starting with some insightful discussions, Reethi will introduce you to AWS data strategy. In the session, you will learn design patterns and data strategies for using AWS services to implement your GenAI use cases rapidly. You will also learn how to formulate an effective data strategy in Amazon Bedrock and about data security, privacy, and how to safeguard your GenAI application when using Amazon Bedrock. I request you all to stay engaged and participate actively throughout the session to secure a chance to win exciting rewards. Now, without any further ado, I request Ms. Reethi Joseph to address and start. Stage is all yours, ma'am. Let's get started.
Thank you so much, Vinayak, for that lovely introduction. Hi, everyone who's here. Good evening. So, my name is Reethi. I'm a senior cloud support engineer at AWS. I have over 7 years of experience working specifically on AWS. And in my role, I get a lot of opportunities to explore technologies. And I am an expert in serverless, and of course, the latest one being GenAI, which is something I'm very much interested in. So I've got a lot of chances to interact with customers also who work on GenAI use cases and try to understand what they're trying to achieve with GenAI as well as how they're using it. So in this particular session, what we're going to be talking about is the data strategy for generative AI applications. So this is specifically around what design patterns you would use, what is the different ways where you can use your data with generative AI applications. So some of them are things like retrieval augmented generation, something you must have heard about a lot of times. So this RAG is something we'll talk about, and we'll also even do a hands-on session towards the end. And we'll also look into what fine tuning is and how you can use your data for fine tuning as well as for training purposes. And finally, we'll also be looking at how to use how to make it more secure in terms of the data security and privacy aspects of generative AI. When you're using your own data, you need to be really cognizant of certain things, and these things I will be talking about. And of course, primarily, I want to talk about Amazon Bedrock because that has some features called knowledge base agents, which makes it very easy to implement certain things that you see in generative AI. So, yeah, this is the agenda that I have just covered, and now let's get started. So at this point, everyone recognizes the power of generative AI, and everyone understands that, okay, this generative AI has been this very emerging trend that we have been seeing since the past, since late 2022 and whole of 2023, we've been coming across generative AI, and we've all tried out ChatGPT. We might even try to generate an image based on some topic that we provide. We would have seen a lot of images being populated on the internet, and then we realize that these are generated by a model and these are actually not real images. So we've seen a lot of things these days around generative AI. So, but when you look at generative AI, just how it is given out today, like how you have a foundation model or LLM model, is that it? I don't think so, because that's just going to be the tip of the iceberg, and there's more to generative AI. And how do you get more to generative AI? By using your own data in order to make it better. So, in order to actually use or get the powers of generative AI, we need to talk about using your data. So now this data can be your structured or unstructured data, and it can even be data that you store in your operational databases. So this can be data that you use for conversation state, conversation history, that is for storing certain things about the user. And you might even use for analytics and data lakes. That is something that when used with generative AI, you can really see the power of what it can create. And also in terms of data integrations, you have ETL, capturing and transforming and streaming the data, and also around data governance, around data quality, ensuring that the quality of the data that is used to train the model and the response that is generated, the access controls are in place, there is privacy in place. All these are different things that you need to keep in mind when you're talking about the data for generative AI. So now diving into what is this data for generative AI. So your data could be the differentiator. What does that mean? So basically, what I said earlier was about how you can have an LLM model being given to you, and the basic one that you get as when you get it as such. Now, what you see is that this LLM or this model is being trained on large amounts of public data, publicly available data. And the problem you see here is that you have a certain use case, but it may not be able to do what you want it to do because it does not have access to your data. It doesn't know what output you need, or what input in terms of your data may not have ever touched the LLM model, which is why when you give your data into the LLM and you feed it and you try to get an output from it, the results can be so much better. So we'll also even talk about some applications that we are seeing in terms of how when data when used with your generative AI can be beneficial for it. So the first one being with a more personal virtual agent. So consider that you have an online travel agency and they want to generate personalized travel itineraries. Now, in order to generate a personalized travel itinerary for a person, they need some information about the person. They want to know what are the past trips that this person has gone for, what is their web history, maybe their travel preferences, whether they prefer to travel alone or with their friends or with their families. And based on that, it can create certain itineraries and show it to them. And also, the other kind of data that is needed would be the data that is specific to the company. So this can be like flight information, hotel information, if there are any promotions that are happening at this point of time, all that information is also needed. So basically, a more personal virtual agent will have to consider the customer's data as well as the company's data and then return a response. Now, to give you an example, if you directly go to one of the LLMs and ask them to generate a itinerary for you, it might give you something a little generic. But if it had some information about you, it knew how you travel, details about you, and if it had access to, say, the flight details, when the flights are going to, what are the timings for the flights, and to which places does the flight go, which are the hotels which are currently available. So this kind of information, if it had, it can give you a more personalized response. So that is one of the use cases. Another one is a marketing company that wants to generate ads dynamically based on, say, the new inventory that has come in. So this can be like a real-time inventory, a brand guidebook, or it can be based on previous ads and content. And another example is to create a more relevant conversational search. So this is to answer questions that the customer asks based on internal resources, like for example, from the Slack, from the internal guides, from SharePoints. So it can collect all this information and then provide a more accurate response. So I hope by now you've understood that when you add your own data with a generative AI application, the kind of results that you see is so much better, and it is very much required when you're trying to build an application for GenAI. Okay, so now that we have discussed about use cases, let's look at how do you provide this data to your generative AI application. So let's first look at what a basic generative AI application looks like. So first you have the user who sends their user input to the generative AI application, and then you have the generative AI application which is going to create the LLM prompt which is then being used to send it to the actual LLM. And now the LLM will return the response which is then fed into the which is then returned back to the end user. So this is a very basic flow of how a generative AI application would get an input and then make the request to the LLM and then return the response back. So something that we covered, as we can see in this previous slide, is something called as prompts. So what is this prompt? It's basically a text input that is sent to the AI system, and it is to tell the AI system what it should do, to tell the foundation model that this is the task you need to perform. And there's a concept called prompt engineering, and this is basically creating prompts in such a way that you specifically tell the model this is what needs to be done, this is how you're supposed to do it. So we have seen and experienced that with foundation models and LLMs, by writing your prompts in a certain way, you can get better results. And there are different techniques that you can use with prompt engineering. For example, you can provide certain examples of the input and response that you are expecting, and then you can say that provide a response similar to this. So this is called as one shot or few shot prompting, where you're providing examples and then expecting a response back. Now, the benefit of doing this is that it is you're able to get a more fine-tuned, fine-grained answer, and you're not having to do a lot of in terms of computation. There's no additional computation that needs to be done on the LLM model. There's no training involved. So that way, it's the most simplest way to get a more fine-grained answer. And you can also it also helps with getting the target desired outputs. Okay, so now let's talk about how we can make this better with your data. So what we want to think about is there any specific instruction that you want to tell the LLM? If there is, then you should be putting it in the prompt template. So this is in the prompt, you should be telling it that this is exactly what you want to do. Give me an output like this, and it shouldn't be like this, and it should be like this. So you can write a very specific instruction which is going to be used by the LLM. Next stage is to think about whether this is going to be part of an ongoing conversation. Now, this is also called as getting the conversation state or conversation history. Now, say a user has been talking to the chat application for some time. They have put in some information earlier, and then when it tries to ask a question, you want the GenAI application to be able to use the information that it had sent previously and then return a response, right? Like, for example, this person is trying to trying to ask the travel agent bot for recommendations on where it can go, and it has already shared some information such as, I would like to go to Goa, and I want to go from this state to this state, so I want to go for 3 days. And finally, in the end, it had said something like, give me a travel itinerary. Now, if the LLM model did not have this information about the fact that this person wanted to go to Goa for 3 days, if it did not maintain that history, there's no way it would be able to return a response. In fact, it will be able to return a response, but it will be an incorrect response. We call it a hallucination, where a model is trying to return a response just based on generating data which is not accurate. So this is the reason why you want to maintain the conversation state and history. So this is where you use situational context. And now another thing is, who is this user? What data do we have of them or the request? Now, for example, this particular user, if their data is stored somewhere in a database, And then we can make an API call, fetch that data, and then use that data, add it to the context as well. So that is why you can have data from purpose-built data stores and APIs and use that data added to the situational context. And finally, is there any meaningful relevant data that will help the LLM response? So in the case of the travel agent example, we were looking at the data such as the flight information, the hotel information, all this information which the LLM needs to fetch of the company, and this is called particularly like semantic context information that is needed for the LLM to respond. So that is why we say here you have the semantic context where you can fetch the data from semantic data stores and search. So now looking at this, you can see that you have the instructions for the model, and then you have the situational context, and then you have the semantic context. So you have the three types of context, and then you have the prompt template, which is how you instruct the model on what to do. Then you have the situational context, which is where the conversation state and history, as well as the data from APIs and data stores can be fetched. And the semantic context, which is data from vector data stores and searches. So, one thing I want you to understand is that when we were talking about the instruction, situation context, and semantic context, all of this is going to get added and put into a prompt, which is then used by the GenAI application and then sent into the LLM model. So, that is what we are seeing here. So, the user input, the question that the customer is asking, plus the context that we have generated based on the prompt template, the situation context as well as the semantic context are augmented with each other and then creating that prompt, and that prompt is what we send to the LLM model, and then the response is retrieved. Now the benefit of doing this of course is that the LLM has that contextual information which helps it give out a more accurate response. So now we will talk about retrieval augmented generation. So this is actually what what we have discussed right now around semantic context. This is basically going to be the RAG piece. So what we see here is that you have the user sending a query, and this query is sent to an embedding model. What does the embedding model do? It converts the query into a vector output, and this is stored in a vector data store. Now, as you can see, there's something called as a proprietary data sources there. So that is basically consisting of all vector embeddings of data that is relevant to that particular matter. For example, we will go back to the travel agent example that I was talking about, where you have the company details, flight details, travel information. So all that data can be put into that proprietary data source, and you have a vector embedding of that being created and put there. So embedding model will do that. So when the user query comes, the embedding model also creates a vector embedding of the user query, and it does a similarity search in order to in order to find the other part of the data sources where this is matching with that, and after that it fetches the result of that. So that is what we're seeing at step number 3, where the result is the similar content, and that is used to augment into the prompt and then sent to the large language model. So when someone says RAG, retrieval augmented generation, you always want to think about it in 3 phases. So first is the retrieve phase, where you're retrieving data from the external source. The second step is augmenting the context of the prompt with the retrieved data. And the third one is the generation, which is generating the response by making use of the LLM using the augmented prompt. So the context that has been fetched as well as the user input that is being used to create the response. Now let's look at RAG in action. So now you have uh, the data ingestion workflow. So in the previous slide, I spoke about how the data source is already added into the vector database. So this is that phase where the data source is first chunked into the document chunks. Now you might be wondering why that is required, because the embedding model will always have a certain input token size limit. It will not be able to take the entire file as such. It would need it in different chunks, and it can embed each of those chunks and then store that in the vector store. So now the vector store has the vectorized representation of all the different data from the data source. And then we have the other part of it, which is the text generation workflow. You have the user who sends an input, and this input is being fed into the embedding model in order to create the vectorized representation of it. Now you can see that there's something called as a semantic search being performed in order to get the most relevant data from the vector source. So you have the user's input and you have the vector store, you have the data source. So you want to get the most relevant data from the data store based on the question that the customer or the user is asking. And using that, you have something called as the context created here. And this context is being fed with the user prompt to create the prompt augmentation, and then fed to the large language model to generate a response. So now the question might be, what are vector embeddings? So any text that you have, having the numerical representation of that in a multi-dimensional vector space is called as the vector embeddings. And the reason you would use a vector embedding is because the way in which these vectors are created is such that words or phrases that are similar to each other will have a more will be more closer to each other in this multi-dimensional vector space. So because of that, it's easy to find out words or phrases that are similar to each other. And so as you can see in this example, you have auto insurance and car insurance being closer to each other. So this is because of the vector embedding and that mapping. So in order to create this vector embedding, you have to use an embedding model. So in our examples during the lab, we'll be making use of the Amazon Titan embedding models. And that is something that is available on Bedrock, which we can use for it. So now we have the flow again, where you have the differentiating. You're using your data, using the semantic context from the vector data stores and search. You're fetching that data. You have the situational context, like explained before, and you have the prompt template. Now it generates the engineered prompt, sends it to the LLM, and then generates the LLM response, which is then responded back to the, and that response is returned back to the user. Now let's move on to another data pattern, which is about using fine tuning. Now, a fine tuned LLM model, we'll go into the details of what fine tuning is in more detail in the next few slides. But basically, it's just around training your large language model with your own data. Now, what you saw previously was that the semantic context was at the bottom, because that is being returned from your vector data stores and then augmented into your prompt and then sent. But what you're seeing with the fine-tuned model is that you have the LLM model, and the semantic context is now coming from the fine-tuned LLM model itself. What that means is that you're training the model with your own data so that it knows or it has more information about the requirements. So based on the use case, like for example, certain things about the booking, all of that could already be stored, not stored, been provided or trained. The model could be trained on that data, and now you no longer need to pass that as a semantic context anymore because now the LLM model has been trained on that data. Okay, so now just to summarize what we just discussed so far, so we looked at how to provide data using RAG approach, where you're context engineering using RAG with foundation models, and in this method, basically you have you're going to augment the data, entire information about the prompt and the context and the semantic context, as well as the details about that is added to the prompt and made into a context, which is then used by the foundation model to return a response. And the idea is very simple. It's just that when you're giving all of this information to the model will have more context, more understanding of the situation, and will be able to return a response accordingly. And then the next one being fine tuning a model. So this is basically when you fine tune using your curated label data. Now what you need to understand here is that you need to have the data to do this fine tuning. You must have a label data set in order to train the model using that data. And in this process what we're seeing is that it's a little bit more complex than using a RAG approach, because you need to, we will discuss this in the future slides, but what it is that you need to have some amount of AI/ML knowledge if you want to fine tune it on SageMaker. But say you're using Bedrock, then it is quite straightforward on Bedrock. And the final approach is training your own purpose-built LLM. So this is when you want, you have a very specific use case, and you want to use your own data for to train the entire model from scratch. So that is also possible. But the thing is, of course, the complexity is going to be the highest when you're training your own LLM model. And of course, when you are training your own LLM model, maybe you can use an approach where you're using SageMaker or SageMaker Jumpstart, and you need to have a proper amount of good quality data in order to get a good output. So this is a very good representation of the three different data patterns that we discussed. Now, the reason you have RAG at the bottom is because it is the most easiest to implement. And then you have the fine tuning, and then you have the training your own purpose built LLM. So, in terms of complexity, RAGs are going to be the most easiest to implement, and fine tuning would be a little more complex than RAG. And training your own data set, or training your own LLM model using your data would be the most complicated approach. Now, in terms of the purposes, so what we're seeing is that uh, if you're using RAG, then you are using some of your data in order to tell the model that this is how you want to do it. So this is like you're using the general model, but you're adding context to it. But when you are fine tuning it and training it, you are making it specific to your use case. You're making the model to be used for that particular use case itself. So of course the response can be better. Again, depends on your data, and as well as the model. Okay, so now we will dive a little bit deeper into the concepts of RAG, which is context engineering using RAG. So now for this, let's look at the example of a generative AI interaction. So as you can see here, we have a person who's asking for getting a car insurance, and the model responds, "Good morning, Bob," with the name of the user, and also goes on to say that you drive a 2021 BMW X3 and live in so and so street. Is that correct? So it has given out a very polite response. It has got details about this person's name, the car, their address, and then finally it has returned the insurance policy details. So that is what we're seeing here. So now we're going to look at how this can be implemented. So here the user input was just that I'm interested in getting car insurance. So that is what the user had provided. But with prompt engineering, this is what we do. So first you have the prompt template. So what we see here is that we have the prompt template that says that you are a conversation agent for this insurance marketplace, and responses to be just questions are written to be helpful and inform in an unbiased manner, and then you can confirm your responses. So you can see that that's the prompt template that has been put in place. So this is the instruction for the model, and then you have the situational context, which is information about the person, about the user. So then this situation context is fetched from maybe the data stores. So information that Bob lives on so and so street and owns this car, and these are his family members. And then we have the semantic context, which is derived using RAG. So now you have the insurance policies, information about all these insurance policies can be placed in a vector data store. And using RAG, it can be fetched. And what we see here is that now the prompt engineering prompt has the prompt template. Then you have the situational context. Then you have the semantic context. And finally, the user input is getting added, and then you have the LLM response being generated based on this entire context, where you're fetching where you have fetched the prompt template, the situational context as well as the semantic context, and then added the user input in order to generate the LLM response. Okay, so now we look at the mapping to the common framework. So we're going to talk about LangChain here. So LangChain is an open source framework which makes it possible to it gives you a lot of modules that you can use with your large language models. And in this case, we are seeing that you can use certain classes like the prompt template class for passing the instruction. And in order to get the situational context, you can use the DynamoDB chat message history. And in order to retrieve the semantic context from the vector data stores, you can use the Kendra as well as the OpenSearch retrievers. Uh, Now let's look at how to map it with Amazon Bedrock. So Amazon Bedrock makes this a lot simpler because you can use something called as Amazon Agents. And Agents is doing exactly what we're seeing in terms of chaining the multiple actions together. So you create an agent, and you also create something called as an action group. Now this action group is basically a lambda function that can be triggered. For anyone here who doesn't know what a lambda function is, it's basically a serverless compute a resource, and it is basically like a service that you can use to run certain tasks on the cloud. And it's serverless, so you don't have to worry about running it on an EC2 instance or a server, and it can be used to perform specific tasks. In this particular case, it can be used to fetch certain data from a data store. So it can be used to make that API call. So now the agent is orchestrating and making sure that this agent action group is getting called. And then for the semantic context, we have knowledge base. We will discuss knowledge base in detail. So, but knowledge base is basically what you use for creating a RAG solution with Bedrock. It makes it simple to create. So you have a data source. You will be able to add that into a vector data store, and the vector indexing can be done in order to fetch the semantically similar data. So it does all of that in the background and makes it so much easier to implement a RAG based solution. So now let's look at how we would architect this solution using the data patterns. Okay, so on the left hand side, what you can see is that the user interaction. So you have an end user who sends the request to the generative AI application, and then you have the conversation state history which needs to be maintained, and the generative AI application is able to fetch the details from the conversation state by asking it for that particular details, like for example what the user was previously talking to the agent about. And on the right hand side, what we have is more around the batch or streaming processes, how the data can be obtained from there and used in the semantic context. So let's look at the RAG pipeline in some more detail here. So the RAG pipeline, as you can see, is consisting of the entire the data stream and batching of the data, sending it to the data lake, and then processing it, and then it goes into the semantic. It gets used for the semantic context in RAG. So now we're going to look at the complete flow of how that takes place. So first you have the end user who interacts with the generative AI by asking a question. Then you have the prompt template. Now you want to retrieve the relevant prompt template. This could be stored in, for example, S3 or something. So this is retrieved. That is the second phase. And then you also want to fetch the conversation state and the history. So any previous conversations that has taken place, the history of the previous conversations, all of that can be fetched. And then the next thing is the situational context. So this is information about the user profile or any other data that can be relevant, that can be fetched. Then you have the tokenization of the original question. So you must be wondering why this is done, but this is going to make sense with the sixth step, which is now with the question that is embedded. So now you have the question that the end user asked being embedded into the vector form, and with that question you have point number 6, which is to run a similarity search of that question versus what is present in the vector data store in order to fetch the most matching text results. And this is going to be used to generate the prompt to create the entire context and then send to invoke the LLM model. Once this is done, you also want to go back and update the conversation state history with the details about this particular interaction. So that is what we're seeing as step number 8. Okay, so now we looked at what was happening in the background with RAG. Now let's look at what happens, or where is the data stored, or how is the data in this particular setup managed. Okay, so first you have the user interacting with the generative AI application, and you have the prompt template that is to be returned. And this prompt template, like I said, could be returned, could be stored in an S3 bucket. It could be in a database. You can even have it as part of your source code, and you can use version control in order to manage it. And the other part being the conversation state and history. Now, this information can be stored in Amazon DB, DynamoDB or Document DB or Memory DB. Basically, in wherever it delivers in memory read latencies, those are suitable for storing conversation state and history. Now, the next step is the situational context. So, for situational context, you can use Aurora or DynamoDB, DocumentDB. If you have a more complex use case, you can use a graph database like Neptune. And then you have the semantic search. Now, the semantic search, you can use Amazon Aurora and you can use PG Vector, or you can use Amazon Open Search Service, or you can use Amazon Kendra. Now, how this is used is if you're using Bedrock, it makes it a lot simpler, because what we saw previously is that you need to create the embedding of the question, and then you need to do a similarity search for the question versus the data that is already there in the vector data source, and get the matching content, and then that needs to be fed into the fed to create the context, and then fed to the LLM model to return the response. So there are a lot of stages and steps involved, as you can see here, because you do need to think about the steps that we discussed here around 5 and 6, where tokenizing, get the question embedding, and running that similarity search, and then invoking the LLM again. But if you are using Bedrock, it's a lot simpler, because Bedrock makes it possible to use knowledge base, where you can specify your data source, and if you want, you can also specify a vector database, and then it will be able to do everything in the background so as to check the similarity and get the data to retrieve the data that is most relevant to that particular topic. And finally, the last step around updating the conversation state and history, again, you can use Elastic Cache in order to store this conversation state and history, as well as the prompt template, so that you can get better response. The response can be faster. So that would be basically caching. Okay, I see a question from Amelia. For sites like insurance or airlines, isn't it a bit risky to train the large language model with sensitive information? Okay, yeah. That is a very good question. So, yes, that is right. So you cannot, whenever you're using generative AI for any of your applications, you always want to think about, is it okay to use my data to do this? And you so as a company, every company has certain protocols in place and has legal policies in place, and you cannot just use anyone's data like that. For example, certain compliance requires that you shouldn't use customers' PII data. There shouldn't be anything about user names or user age, or any of that should not be used in the model, because you wouldn't want that. So in such cases, you can. I will talk about it in some of the future slides. So we have Bedrock certain features you can use to mask sensitive information and then use that to train the model. Yeah. So yeah. So basically, there are certain things in place that you can do to prevent that. Okay, now going back to the topic on RAG. So, what we saw earlier was about how it could be a resource intensive and time consuming task, because you don't need to convert the data into embeddings, you have to store the embeddings, and you have to build the integrations with the vector database. And we also saw how you need to convert the user input into a vector form and do a semantic search and get that result, and then use that result. So those are the various things that you need to do for RAG, but that's where knowledge base for Amazon Bedrock comes. So knowledge base is fully managed support for retrieval augmented generation. Basically, all you need to do is provide your source data in an S3 bucket, and then Bedrock will be able to fetch the relevant text data and will convert it into the embeddings and will store it in your vector database. If you do not provide a vector database, if you don't have one, knowledge base itself will create one for you in OpenSearch, and then it will use that for performing the vector embedding. So basically, it's just a single step when you're using knowledge base, because you're just providing the data and then expecting, and then you can expect knowledge base to return the relevant information from there, and that will be used to generate the response. So that's why we say that it's a fully managed support for end-to-end RAG, and it enables to securely connect to both our to foundation models and the agents to the data source. So Bedrock agents, like we spoke about, is how you can make certain API calls by using the Lambda function to fetch certain data, to perform certain computing tasks. So all of that is done with agents, and even that can be integrated with knowledge base in order to get more relevant responses. And it automatically converts the text documents into the embeddings, and it's going to store the embeddings in your vector database. It retrieves the embeddings and it's augmenting the prompts, and it also provides source attribution. So this is important because sometimes we have seen this problem of LLM models hallucinating. So giving that source, that this is where I got this response from, really helps to validate that, okay, this is relevant information because it's coming from this particular source. Okay. So uh, retrieve and generate API call is something that can be used with Bedrock. So what we have here is so this is just to show you how simple it is, because you're just going to make one single API call in order to fetch the relevant details. So what you see here is that the user has the search query, and then you have the retrieval where it can go and get it from the vector data store. So this can be any of these options like Pinecone, Redis, OpenSearch, Aurora, and MongoDB. So all these are supported. So it will retrieve the data that is relevant to that particular search query, that is used to generate a response. So this is a single API, it's comprehensive, and you're being able to get a RAG based solution just with a single API. So that's the benefit of using knowledge base. Okay, so vector databases for Amazon Bedrock. So we looked at OpenSearch, which I mentioned. So OpenSearch serverless is supported. Then Redis Enterprise Cloud, then Pinecone, Amazon Aurora, and MongoDB. These are the vector databases that you can use with Bedrock. Now, if there might be a question around which is the right database vector data store to use. In most cases, the one point that matters the most right now would be familiarity. For example, if you're already using Aurora and your existing data is on Aurora, then it might make sense to use it because it would be a lot faster. You would be able to create your GenAI application and integrate it with this particular data store a lot more quickly because you already know about it. So in that case, it is making sense to go with that particular data store that you're already aware of. You also want to look at the scalability aspect of it in terms of the number of vector dimensions that is supported, number of embeddings. So as per your use case, what is it that you require, as well as the performance in terms of the recall rate and the queries per second. Another important factor is, of course, the cost. So you might want to consider the cost as well, and you'll also have to think of trade-offs in terms of the cost and the recall rate and the throughput. For example, the cost might be lower but the recall rate might be lesser, the throughput might be lesser, but maybe that is enough for your use case. So depending on that, that is how you evaluate the vector data store. Okay, now let's look at the other data pattern, which is fine tuning a foundation model. So in this case, what you have is you want to get a better response from your LLM model. That is when you can fine tune it by using your labeled data. And basically, you will also have to update some hyperparameters. Hyperparameters are needed to tune the model, and based on the model, the values for this hyperparameter that you need to set can vary. So some of the relevant hyperparameters are things like epoch, which is the number of times it needs to be trained. And you don't want to set a very high epoch value because you don't want overfitting to happen. So there are a lot of things to keep in mind when you are setting these hyperparameters. Talking about the benefits of fine tuning, so you get a better, higher quality response, and also whatever we've been talking about till now in terms of context, in context learning. So where we were adding the context and we were using RAG. You also might have seen that the size of the input that was being sent to the model was quite bulky, right? Because you have the situational context, semantic context, the prompt template, all of this gets added. Now, you should keep in mind that when you are using an LLM model, you're usually charged for the input size as well. So when you have a larger size input, it can increase the cost. And whenever you were using things like RAG, that is how it will be. Like you need to provide the context in that way. But when you're using fine tuning, you no longer need to provide that context in that way because, as if you can recall, how the semantic context is going to be a part of the LLM model because you've trained it on that data now. So because of this, you can have some token savings because of the shorter prompts, and even the latency of the request can be lesser. But of course, you also want to keep in mind that the results of fine tuning a model depends upon the data that you're using to train the model, as well as the quality of the model itself. So you would have to test that out and see whether the response or the that you're seeing is good enough, whether the data that you're giving it is good enough. Now let's look at the data, the architecture for fine tuning and training the LLM. So as you can see, it's very similar to what we saw earlier when we were using context engineering. So you again have the transactional user information. You still need conversation state and the prompt template. You still need the situational context, and you have the generative AI model here. And here we're looking at Bedrock and SageMaker. Now, what we're seeing here is that you have to do some fine tuning, and for that, you need the data. So, let's talk about that. So, for example, you can use something like SageMaker or SageMaker Jumpstart. And if you were to use SageMaker, you can it helps you to create, build, and deploy machine learning models. And but on the other hand, with Jumpstart, there are certain pre-trained models that are already available, and that can be used on Jumpstart. Now, in order to start the fine tuning, you have the process of getting, you need that data to come in from somewhere, right? So let's look at that. Okay, so your data can come from, say, the data lake or data warehouse that can be S3 or Redshift, and you also want to think of what kind of data you're using to train your Bedrock model. So, not just Bedrock, just one second. Yeah, let me just go back and explain one more thing. So, with SageMaker, it would be a little more complex in terms of training the model, but with Bedrock, the integration with the data is very simplified, so that you just have to provide the data, and then it takes care of the rest, and deploying that model and using that makes it a lot easier. On the other hand, if you were using SageMaker, you would have to provide your data to the SageMaker, and you would have to train it. You have to write your code in order to specify that this is how it should be trained. All of that is put. And then after that, you also need to think about the inferencing part of the generated fine-tuned model. So that is where you want to look at the hosting options. Like SageMaker provides the inference endpoints, various kinds of inference endpoints are available. So one of those can be used. But this process is a lot more straightforward and simpler when you use Bedrock, because you can just provide your data source, and it takes care of providing you with the hosted environment. So you will be able to access your LLM model with just simple API calls. So yeah, so this particular the architecture will be for fine tuning using the Bedrock. So here you have the Redshift and the S3 data in Redshift to S3. I also want to talk about what kind of data it is. Now, if you consider an example of, say, a customer support generative AI application, the data is quite easy to get, because this could be like the customer issue is the user input, and the output is possibly what the agent responded back. So that response is already available, so it's easy to get access to high quality data. But sometimes in certain applications or certain use cases that you might have, you may not have the relevant data sets. So that is where you want to use some human labeling. So there's a service called Amazon SageMaker Ground Truth that makes it possible to do this human labeling. And then after that, you want to take this data and put it in this particular format of prompt plus what is the response that is expected. So this is put into JSON lines and added to the S3 bucket. You then instruct the Bedrock that this is my data source, and this is the foundation model that I want to fine tune using my data. So then after that, it returns a custom model. And then you should also provision this custom model. You'll have to specify the kind of throughput that you're expecting, and then Bedrock manages all of that, and then you'll be able to use your custom model. Yeah, so this is a lot simpler than doing it on SageMaker, because, of course, with SageMaker, you also need a good amount of AI/ML skill set to understand about the models, which functions to use, and how to train it. So obviously you need to write all the code for that. But in case of Bedrock, it's very much simplified. Okay, when you look at the architecture design patterns that we discussed, we looked at the RAG as well as fine tuning. There's also training your own model. Now you can use these different design patterns to be used with one another, like complementing each other. And what you want to understand is that when you train a model, you want to train it when you say your domain specific data is set infrequently. Now, fine tuning makes sense if it's getting updated occasionally. And RAG, on the other hand, makes sense to use when you have specific data sets and user profiles that is going to change in real time. Also, one more thing to consider is that, of course, like we said before, the complexity is the most with training, and with RAG, it is the least. even the pricing and the cost of doing it will be the least with RAG, and it's going to be higher when you train your own model. Uh, so, so when you're considering which approach to go with, try to go with RAG first and see if RAG is able to solve or give you a good enough output, if the accuracy is good enough. If it isn't, then you can consider fine tuning. If that is also not good enough, then you can go with training your own purpose built model. Because in terms of ease of implementation, RAG is like what is going to be like the fastest and easiest to do. So you always want to try RAG first, and then you might want to consider fine tuning or training your own model. Uh, okay, now we will talk about data in terms of how Amazon Bedrock keeps your data secure as well as private. None of the data that you use on Bedrock that you pass as a user prompt is going to be stored or used to train any of the underlying models. It's not going to be shared with the model provider either. So, for example, we have many different model providers. We have Anthropic giving us Claude. Now, we're not going to share your data with any of these model providers. We're not going to store your data anywhere. So that is what this means. And all the data is also encrypted in transit and at rest. And if you're using your data to customize your model or to fine tune your model, then that is also transferred securely using the customer's VPC. And even the data that is being transferred will be encrypted using a KMS key. This can either be the service provided KMS key, or you can even provide your own customer provided KMS key. And the data is going to remain in the region where the API is processed. And this is in order to, of course, ensure the compliance. So it does support GDPR, SOC, ISO, CSA compliance, and HIPAA eligibility. So, like I said, the customer data is not used to train any of the models, not the Amazon Titan model or any of the other foundation, or not shared with any of the other foundation model providers. And it's always used in the same region that they were created in. And in terms of data security, you have support for private links, so that if you want to ensure that there's a private connection between your data and Bedrock, that is also possible by making use of VPC endpoints. And you can integrate there is integration with IAM in order to restrict access, so that you can restrict the model access only to certain users, and even console access can be restricted. And you can use Cloudflare to monitor the API activity, and you can also troubleshoot issues as you build the solutions. And you want to remember that these fine-tuned models are encrypted and stored using service managed keys, and you can also use customer managed keys to encrypt the fine-tuned models. Now, okay. Now we'll talk about guardrails for Amazon Bedrock. So, this is basically a feature that allows to safeguard the data, the prompt, and the response. So this is something that is in line with the responsible AI policies. So you can make use of guardrails in order to ensure that organizations have certain policies in place. They might be trying to be certain compliance regulations might be there. So in order to be compliant with those things, you can use guardrails. So now, what are some of the challenges we see with generative AI and LLMs these days? Is that sometimes the response can be biased. It's trained on large amount of data, and sometimes it tries to tries to get certain patterns out of the data, and the result is that the response is biased, or there can be stereotypes. Then there is a possibility of getting the user information, or the user information can get, if the user information is comprised, then there is a problem around the privacy of the data that you use. And also, if the model returns a harmful or offensive response, if it's providing some insults. And one of the main problems is around hallucination, because if it provides or returns a response which is undesirable or it's irrelevant, again it can also mislead people, because it's not giving a source and saying that this is where I got the information from. So sometimes you don't know whether it's a hallucination or an actual correct answer. So those are some of the challenges we are seeing with generative AI, and with the LLMs. So guardrails helps in certain cases, because you can have content filtering. You can say that certain things should not be, if the user is saying certain things, then return a response like this. Or you can deny certain topics. You can say that these kind of topics should not be returned. Now, to give you an example, so say you have the travel agent chatbot, and the travel agent chatbot does not want the users to ask about its competitors. It does not want the users to ask about pricings and negotiation for the pricing. And if there's an emergency situation, then it doesn't want the chatbot to handle those kind of things. So you can do a content filtering, as well as you can specify that certain topics should not be allowed. And that will help in order to prevent certain things from being, the prompt, at the prompt level also, you can mask it, or you can redact it, or you can send a response that says, I'm not allowed to answer such a question, please reach out to so and so. So those are things that guardrails helps you with. And another one is redacting sensitive PII information in FM responses. So, for regulatory needs, for compliance requirements, it is possible that you shouldn't be sending information which has any user details, shouldn't have the user's email address or the phone number or their name. So, you can use this PII redaction feature in guardrails, where you can specify that if there's a name or an email address or a credit card number, what you need to do is you need to mask it. So certain things like that will help make sure that the application that you build is still compliant with the required compliance. Yeah. Uh, So, talking about how this guardrails works, first you have the user input, and there is this intersection of the user input and even the output that the foundation model generates. So, you want to remember that guardrails helps for both the prompt as well as the response that it generates. When you create this guardrail rules, you can specify whether you wanted to apply to the prompt or the response. And that is where you can put that certain topics should be denied, certain content should be denied. If there's PII information, redact that, do this word filtering. And if it matches with any of these filtered, with some topic that should be denied, then it is possible to configure the guardrails such that it returns a final response. So, for example, if the user is asking for some information which is not, which is violent, then it can identify that, and once it identifies that, it can return a final response instead of having it being sent to the LLM to generate a response from there. Okay, so now summarizing everything that we have been discussing. So you always want to think that when you're using generative AI with your data, you need to look at an evolving data strategy. So earlier, you would have your structured data, you would have your unstructured data, you would fetch data, the valuable data part or the metadata from it, and this unstructured data is usually just stored somewhere. But now we are seeing that unstructured data adds a lot of value for generative AI, and it makes sense to have this data stored. So that is why you might want to consider maintaining both native and vector formats of that particular data. Then you want to think about integrating. So how do you, so you have these various data sources. Now how do you integrate them to provide a single view? You want to prepare your data for this fine tuning and model training and vectorization. So you also want to think about what is the ETL strategy you'd use, what are the ETL tools you'd use, and even there is the zero ETL integration between Aurora and Redshift. So all of this will allow your data to move uh, easily between the data sources. And then there is the concept of governance and governance. So you want to think about the data security and the compliance of this data. So all this while we've been talking about adding conversation states, semantic context, situation context. You also want to know whether when you create a GenAI application that fetches all of this information, and if anyone has access to it, is that right? Like, do all users need access to certain details like that? Like, for example, if it is using a RAG-based solution where it's fetching context from a data store. Was this data restricted to only certain people before? Now, with this GenAI application, is it going to be is it going to allow access of this data to others as well? So you wouldn't want that. So you would want to have you would want to make sure that you're restricting the access. For example, that particular model should only be restricted to certain user sets, and you want to make sure that you have guardrails in place in order to filter content and the topics, and even the PII redaction. So yeah, these are the different ways in which you can do the you can have the data security and governance in place for the data that you use with generative AI. So this brings us to the end of the session. I do see that there are questions. I will answer them, but I'll just walk you through the catalog that we can do right now. As in, this is going to be like a hands-on exercise where you can implement a RAG-based solution using knowledge base. So you will see that how it's possible to use data from your S3 bucket in your data, and to get your Bedrock to return a response based on that particular data. So those of y'all who have your AWS accounts, y'all can use that. And in case y'all don't have it, no problem. I'm going to share a link which you can use at any point in time. You can go through that and reference that, and you can try that out as well later on as well. Okay, so just to walk you through the session, the workshop. So what you're trying to do is to implement retrieval augmented solution using knowledge bases on Bedrock, and so you can go to the second link you see here, running from your own AWS account. So the third header on the left side. So that is what you want to follow. And this needs to be run in the Oregon region. And you're provided with a cloud formation template that you want to download from here. Once you download that, you should head to cloud formation, and that is where you can provide this particular resource. So I already did it, but I'll show you how to do that as well. So you click on create resources and you specify a new resource, and you want to select use a sample, use an existing template and select the upload a template file option, and you want to choose the file. So this is where you specify this particular file that you have downloaded. So you want to upload that. So I'll just show you that as well. Yeah. So once you have uploaded it, you'll have to provide a name for the particular CloudFormation stack. The other components can be left as default, and then you will have to also acknowledge that CloudFormation is going to create these IAM resources, and then you can deploy the stack. And the stack will create the resources which you'll need. It will create an S3 bucket, but there is also an there's also the file that needs to be added to the S3 bucket that needs to be done by you. So here you have to download the file from here, and then you can navigate to that particular S3 bucket, and you have to create a folder called knowledge base, and then you need to upload the file into that particular folder. So yeah. So you provide the name here, so you can say, so you add all of that, and then you click on I acknowledge, and then you hit submit, and then that should create the CloudFormation stack. So since I created it earlier, it is available, and what you can see here is that it has created certain resources. So from here, you can go through the S3 bucket. So this is the S3 bucket to which I will be uploading the data source for my knowledge base. So as mentioned in this particular step, you need to create a folder called as knowledge base, and in the knowledge base folder you add the file that they have provided. So once you're done with that step, one thing to keep in mind is that the Bedrock models, you need to enable the access to them. They're not enabled by default. So what you need to do is you need to click on enable the model option, and you can specify which models you plan to use. So for now, I can select the Anthropic and Amazon models. Uh, yeah, you might see this error because certain models you may not have access to. So you can ignore this, but you should see that the model that you plan to use should be enabled here. Okay, so that is what this step is about. And once you do that, you will be able to create the knowledge base. So where we select the knowledge base and we click on create knowledge base, and we need to have an IAM service role. So this can be created by Bedrock itself. So you can leave that as the default. And for the data source, so I have the S3 bucket where I have my data. So that is what I will be using. I will click the bucket. Okay, so this has provided with the S3 URI, and I can click on next. Now this is the embedding model that should be used to convert in order to create the vector representation of the data. So as per the workshop, you can go with Titan embeddings G1. So that is what I'll use. And also I'm going to go with quick create a new vector store. So this will create the Amazon OpenSearch serverless vector store. If you have an existing vector store, then you can make use of this option and you can specify it. I don't have one, so I'm going to go with this option. And then I will click on create knowledge base. Now, once I click on this, what you see is that there's a notification saying that the vector database is getting prepared in OpenSearch serverless. This could take a couple of minutes. Once this is done, I can sync the database, sync the data with the knowledge base, and then I would be able to test it. Okay, so while that is happening, I'll also give you a quick demo on guardrails. This is not under free tier as per my knowledge, Likita. Uh, the OpenSearch serverless will cost. S3 also, when you upload data, it will cost. So you might want to look into that before you do this. If you have some credits, you can use it to test this out. Okay, so now going over guardrails for Bedrock. So let's look at the steps to create a guardrail. So while the knowledge base is getting created, so this is where you can provide a name to the guardrail. And I'm going to leave this as default for now. You can customize the encryption setting. And this is where you can specify content filters. So I can enable this. So as you can see, it can be configured for prompts or for responses, and it provides you various options as well as the strength of it, whether you want it to be a medium filtration or a high filtration. So in this particular workshop, what we'll do, enable this, and then we add a denied topic. So let's enable for both, and then let's add a denied topic. So now in this particular case, let's add about investment advice. You don't want your model to return anything related to investment advice. So that is the name. and you don't want it to provide any recommendations. That is what the definition is. You can add sample phrases, like for example, is investing in stock better than bonds? So add that phrase, and then there's one more phrase you can add about should I invest in gold? So let's add that as well. And then it's kind of on this. Okay, so the two phrases have been added. So this is the topic that is denied. Now you can also have word filters. Let's see. Okay, so certain words like cryptocurrency and Bitcoin can be blocked. Let's add that as well. Okay, and then Bitcoin can be blocked. Okay, and now the PII data. So let's see what I want to do with the PII data. Okay, so you want to block. Okay, so you want email addresses, and here you see that there's an option to either block or mask the data. So block would mean that it would, once it detects that that particular type of data is there, it will return a block message immediately. The other option being mask, which is it replaces it with an identifier. So in this case, we want emails to be masked. Okay, and we want to add one more for credit card, but we want to set it as block. Okay. So as you can see, there's even an option to add your own regex pattern in order to do certain custom type of data matching and to identify that particular data types. And this is where you specify the kind of response that the model should return when it gets any blocked, when it tries to block any particular content or topic. So specify. So we can leave that as default, and then we can hit create guardrail. Okay, so our guardrail is ready. Let's see if we can test it now. So this is where we want to, we can summarize the call center chats transcript, and here what we're seeing is we're providing an email address. So if you recollect, we have set it to mask this particular email address, and let's select a model as well, or I'm going to go with Third Sonnet, and let me hit run. Okay, so what we see here is this is the model response. So this was supposed to be a summary of this data, summary of this transcript, and the summary was generated. It had the email address, but you can see that the final response, on the other hand, does not have the email address. It is masked. So that is exactly what Bedrock guardrail has done for us. If you look at the trace, you should be able to get more details. Okay. So as you can see, from the model response, we have the sensitive information of the email address getting masked. So yeah, that is what happened there. Let's go back and show you the Bedrock knowledge base now that should have been created. Okay, so it is ready. I need to sync. So what sync does is it fetches the data from the data source. Once that is ready, I should be able to test it out. So the next step is to switch off generate response. So this option is to generate a response from the LLM. If I don't want a response to be generated and I just want to see the retrieved data from the knowledge base, then I can turn this off and then I can ask this question and see what kind of response it returns. So while that is loading, I can also talk about the Bedrock agents. So this is where you have Lambda functions as okay. Yuvraj has a question around whether I used. Did you create agent for Bedrock? No, I haven't created it, but in this particular workshop, the second thing that you can follow is around creating the agent. So I'll just talk about what it is, and you can try this out as well. So basically, you have the action group, which is the Lambda function, which can be invoked, and this is very helpful when you have you want to fetch data, you want to do some computation, then you can have the Lambda do it, and you can even integrate with the knowledge base in order to get the response. So the agent is responsible for chaining all the actions together, and it takes care of generating that particular required instruction and calling the Lambda function, calling the knowledge base. All of that gets managed by the agent itself. So the entire orchestration gets managed by the Bedrock agent. So if when you have a use case where you want to fetch certain information, that is when you would want to look at using Bedrock agents. So once you complete the knowledge base part of the workshop, you can go ahead and try the agents as well. That's a very good beneficial use case and a beneficial feature of Amazon Bedrock. So I saw that there was a question around Bedrock pricing. So you want to know that you are charged for both inferencing as well as if you're creating a custom model, then you'll also be charged for provisioning that particular model. So that also you will be charged, and the pricing is based on the input tokens. So like I mentioned, if the size of the input that you're sending is larger, the price also increases based on that. So I'll share this link with you. Okay, sync has been completed. Great. Now let me turn off generate responses so that I just want to see what is the kind of data that is being returned. Okay, so now uh, so this is the question that I can ask. And let me paste that. So what you see here is that it has fetched uh, results based on my question, and you can also see that it shows data, source data. So it tells me from where it got this particular data, the data source ID, and what is that chunk of data. So that is what I can see here. Now if I wanted to generate a response by making use of this, that is also possible. So let me turn on generate responses, and I'll have to select the model that I want to use. So I can use Sonnet, for example, and let me ask a question here. So I'm going to ask the same question again. So as we saw earlier, there was like a chunk of data, different data sources. It was able to fetch that data and give it to me. But now that I've asked the question to the LLM with the generate response option selected, it's going to take the data from the data sources, augment it, create that new context. With the context, it's going to send the prompt and then generate a response. And as you can see here, the data also has a reference number been added there. So here is the reference from which it got this particular information, and it generated this response as well. I hope that's clear. Okay, I see a question around when there's a need to build a custom model instead of a RAG-based solution. So a custom model is when you have a specific use case and you're not seeing any, if you're the existing models that you use, if you're trying to use it for a particular use case and you're seeing that the results are not accurate enough, then you can consider using a custom model trained with your own data. So this is when you want to get a very specific response, very specific use case, and you have your own data. So that's very important that you have your own proper label data in place, because that is basically going to be the differentiator between a good model versus a bad model. So if you have all of that in place, you can create a custom model. But if your use case can be implemented with RAG, and the RAG is giving good enough a result, then you can use RAG because the complexity is lesser. The Whenever you're training a model, example, you're using SageMaker, you also want to remember that training is a very resource intensive task. So like a lot of GPU is required for that. It is very expensive. GPU is expensive, and the cost of training would be high because of that, and the complexity that is involved, like I mentioned earlier, especially if you're using SageMaker, you do need good amount of knowledge about how these AI/ML models and how to use them and how to train them. So all of that is needed. But on the other hand, RAG is more straightforward, much more simpler and easier to implement. Cost would also be lesser. But so my suggestion in this matter would be to see whether the accuracy that you're looking for can be achieved with RAG, else go with fine tuning, and then you want to consider having your own model created. uh, Using Bedrock, can we build new models? No. So Bedrock gives you a list of models. Like it has, so you have the Amazon models, like the Amazon Titan models, and also there are models provided by other providers, like you have the Anthropic models, the Cohere models, and even from you have the Jurassic models. So all these models are present in Bedrock, and if you want to like use your own model, see, one option is you can either fine tune or pre-train or do some training of the model, and you can create a custom model. There is an option where you can import your model, but this is still in preview, and you'd want to see whether it works for your use case or not, because there are certain things to keep in mind. But the what we normally have are these base models, and this is what you can use with your thing. But otherwise, if you are importing a model, it's not like, for example, RAG is not supported if you're using an imported model as of now. So certain things like that needs to be kept in mind if you want to try and import your own model into Bedrock. Do we need code for implementing RAG? Uh, for implementing RAG, so right now what I showed you with knowledge base, I did it entirely on the Bedrock console itself, and here I did not use any code. You can, however, use code and write the API calls in order to create the knowledge base and get the response back from the knowledge base. Instead of running it from here, I can have an API call return that response back, and then I can use it in my application. Now, if you have a particular use case where you want to use RAG and you don't want to create your own code, my suggestion would be to check out Amazon Q for Business, because in this it makes it very easy to create a chatbot based application implementing a RAG based solution. So, Amazon Q for Business is what you should consider if you want to create a chatbot and you don't want to worry about any of the code, because you basically even get the front end that the customer can use. So yeah. Yes. Party Rock does allow you to upload a document and extract the text from it. But what you want to keep in mind is that's not a RAG-based solution. That's like a prompt-based solution where you're giving this data and it's keeping that data in its memory and then using that in order to return a response back. Okay. Yeah. Any questions? Difference between Bedrock and SageMaker. Okay, so SageMaker is also a fully managed service where which you can use for creating and building and deploying ML solutions. So it makes it possible for you to if you've ever worked with Jupyter notebooks, it's a Jupyter notebook that is hosted on instances, and that using that you can basically write your code in order to train a model, build a model, and even deploy the model, because SageMaker provides you with an option to even deploy the model into an inference endpoint and use that. Now, Bedrock, on the other hand, is I would say more like you don't have to write the code in order to train it or build it or to deploy it, because you are being provided with these models and you can directly use them. So if I wanted to talk to say the Claude model, I can specify, I can select it here, and then I can ask it questions around mm, so I'm able to do this because Bedrock already has this model in place. But on the other hand, with SageMaker, I would have to load my own model, and then I'd have to send this data to it, and all of this should be done in code. On the other hand, with Bedrock, I'm directly able to so it gives you an API endpoint that you can use in order to in order to get a GenAI an LLM output out of it. So if you look at this, basically, this is like the list of Bedrock API calls that are available, and you can make use of this in your application as well. So you can directly call the Bedrock API endpoints in order to get an LLM response, instead of say deploying it through SageMaker and then getting it. So the entire management of having to deploy an ML model is taken care of by Bedrock, which makes it very much simpler and easier. Yeah, it is the easiest way to build and scale generative AI applications. Regarding building chatbots or knowledge bases with free tier account, I'm not too sure on that because of the charges associated with S3 as well as the open search serverless. Might have to check a bit on that. Not too sure. Okay, if there are no other questions, I think we can wrap up for the day.
Okay, so thank you so much, Reethi, for your valuable insights. So what do you say? How was your experience hosting the session with us?
Oh, I think it was really great. Thank you so much for this opportunity. It's so lovely to see such a great crowd that has so many questions, so curious, wants to know so much more. So I really like that and I really enjoyed presenting today. So thank you so much for the opportunity and thank you everyone who joined. I hope you all learned something new today about RAG and fine tuning and you're able to incorporate that when you build your GenAI applications.
Yes, it was actually quite an informative session for us as well. We are grateful for the time and effort that you have invested in sharing your expertise. It was lovely having you with us.
Thank you, Vinayak.
Now, for the post session activity, uh, the audience, you have to share your learnings with us on LinkedIn. A form will be provided to you after the session for submissions. Post the learnings and the outcomes of today's session in a LinkedIn post tagging AWS User Group Dehradun and the speaker. To ensure your attendance in the session, scan this QR or fill the form that will be given in the chat. And also, most important part, guys, don't forget to complete your task. Remember to complete your task before the next session. Share your progress and reflections with the community to enhance your learning experience. We will be sharing a form in the WhatsApp group also for you to submit your tasks. You have to take a screenshot of your task and share it in the form along with the direct link to your LinkedIn post or the task itself in the form. So make sure you complete your tasks. You can just simply take a screenshot of the QR to mark your attendance. The attendance column will be closed soon, so it is for the active members only, and those who are watching the recordings, for them the attendance will not be available. So that will be all. Thank you everyone for your enthusiastic engagement throughout the session. We trust that your questions have been thoroughly answered and you have found value in the discussion. We have more exciting sessions lined up, so stay tuned for the updates. Follow us on our social media handles for latest news and events. Below in the description, you can find the link to Twitter, LinkedIn, Instagram to connect with us. Thank you once again to all the active participants. Let's continue this journey and make the most of AWS and generative AI have to offer. Have a great day, everyone. See you on 5th July at 5 p.m. on the same platform.